Welcome back to this session. So we solve a problem involving the free body diagrams and application of Newton's second law of motion. The problem reads, a sign of mass 10 kilograms is to be suspended by two strings as shown in the diagram below. Find the tension in each string. So to solve this problem, we draw an appropriate axis around this point where the sign is tied to these two ropes. So let me draw this as my x-axis, and then I draw this as my y-axis. So this is the y, this is the x. So with this axis, then since this line is parallel to this, so this angle will be 45, and this angle will be 30 degrees. So if I call the tension in this string T1, this one T2, then if I draw a right angle triangle here, I have a right angle triangle here, then this will be the direction of this force, this vector, then this is the direction, this is the direction, this is the direction. So this will be T1, tension in this string, because this is the length or the size of this force. This adjacent cosine of 30 degrees. This will be T1 sine of 30 degrees. This will be T2 cos of 45 degrees. This will be T2 sine of 45 degrees. And then for this sign to be suspended, then it's assumed that for these two strings to hold this sign without it being without it dropping, then it means that the acceleration of this system is 0. So net force is given by 0. So x components, or the horizontal forces. Now, when you resolve for horizontal forces, then forces which are acting horizontally are this T2 cos 45 and this T1 cos 30 degrees. Customarily, we take right-hand side to be positive, left-hand side to be negative. So this would be T2 cos of 45 is the same as T, when you add to this other force, but now it's in the negative direction. So minus T1 cos 30 degrees is 0 from this definition. The net force is 0. Then it tells us that T2 is the same as T1 cos of 30 degrees divided by cos of 45 degrees. Now cos 30 divided by cos 45 is root 6 over 2 T1. Call this one equation 1. And then y components or simply the vertical forces, we have, this is the weight of the sign. So I'll have this force, and this the weight. So I'll have T1 sine of 30 degrees plus T2 sine of 45 degrees. But now weight is acting in the opposite direction, so negative W is 0. So that will give us T1 sine 30 degrees plus T2 sine 45 degrees is equals to W. So call this one equation 2. So replace 1 in 2. So we'll have T1 sine 30 degrees plus, so what is T2? We put root 6 over 2 T1, and then you multiply this one by sine 45 degrees, should give us weight is mass times G. Mass of this is 10. So 10 times G, which is 9.8. So sine of 30 is it a half? So I'll have a half T1 plus, so sine 45 times root 6 over 2 gives me root 3 over 2 T1 equals to 98. So plus a half, I get 1 plus root 3 divided by 2, T1 equals to 98. So to get T1, I multiply by 2 over 1 plus root 3, 2 over 1 plus root 3. So 98 divide answer, I get T1 is minus 98 plus 98 root 3. If you put as a decimal, T1 will be 71.74097914 newtons. So which means T2 will be given by, so T2 is root 6 over 2 T1, root 6 over 2 T1, which will be root 6 over 2, 71.74097914 newtons. So multiplying by root 6 divided by 2, you get T2 is 87.86439,627 newtons. So that is the answer to that particular problem. Thank you.